All right. All right, so the video is being recorded. Does anybody have questions on questions 1 through 7 on the summer packet? We're good? Yeah. My other class also went several pages before having questions, so don't be shy, but speak up if you have questions. Also, I don't necessarily see the chat, so kind of speak up if you have questions. All right, no questions on 1 through 7. How about 8 through 16? Any questions on 8 through 16? Give you a moment to look. Okay. Joan, it looks like you unmuted yourself. Do you have a question or?
Should we be taking notes right now?
Only if you need to. This is here's how this goes. The note-taking packet is not being collected in terms of I'm not collecting it and looking, checking off, oh, yes, you did it. The way I'm checking it is by giving you a quiz. So if there's something you think you need to take notes on to learn, then make sure you do. Okay?
Okay, just wanted to make sure. Thank you.
Yeah, no problem. Grace, I see you're, oh no, you're on mute. Sorry. It looked like you were off for a second. All right, no questions on 8 through 16? All right, let's go through 17 through 25. 17 through 25. Any questions on 17 through 25?
Wait, Mr. Lab?
Yes.
I have a question on 13.
13? All right. Okay. All right. Let's give me a second. I'm going to make this, I'm going to zoom in on it so we can see it better. Okay. And I'm going to, okay. You're going to hear a little camera click. So I click. So I click, take a peek. All right, here we go. The point 3,5 is reflected across the x-axis. What are the coordinates of the reflected point? Okay, so we have, here's your y-axis, here's your x-axis, right? Okay, the point 3,5 is 1, 2, 3 to the right, and then 1, 2, 3, 4, 5 up. So there's my point, right? If I reflect it across the x-axis, think of the x-axis as like a mirror, right? Can you guys just mute yourselves, please? Just make sure. Okay. So this is the point 3, 5. Well, the reflection is going to be down here, right? It's going to be 1, 2, 3, 4, 5 units below this point. So it's going to be 1, 2, 3, 4, 5 units below. It's going to be right here, right? So the answer to this is it's going to be 3 to the right and 5 down. So that's going to be 3. And then 5 down would be -5. Okay?
Thank you.
That makes sense? Okay. All right. So we go back to 100%. Okay. Let's try this next one. 17 to 25. 17 to 25. Any questions on 17 to 25? We're good there? Am I going too fast? I'm giving you guys time to look at it. All right. 26 to 33. 26 to 33. Any questions on 26 to 33?
I have 24.
Say it again?
24.
24. Oh, so the previous page. Okay.
I'll just finish writing notes.
Okay. All right. So 24, let me. All right. So 24. Here we go. The chart shows Julie's rate of travel on each of 4 trips. Write an equation that could be used to determine the relationship between distance and time. Okay. So looks like when t is equal to 1, the distance is 50. When t is equal to 2, the distance is 100. When t is equal to 4, the distance is 200, so on and so forth. So what we're basically doing is we are taking the time and multiplying it by 50, right? So the distance is equal to 50 times the time, all right? Makes sense? Because 50 times 1 gives me a distance of 50. 50 times 2 hours gives me a distance of 100. 50 times 4 hours gives me a distance of 200. Does that make sense?
Yes.
Okay, perfect. All right,
I also need 23.
23. All right. The formula D equals RT. Let's make this a little bigger to see. The formula D equals RT gives a relationship between D, the rate of speed, distance D, rate of speed R, and time T. Use the formula to find out how fast you need to drive to travel 252 miles. So D is distance, R is rate, and rate of speed is R. Let me use a different color for that. Rate of speed is R, and time is T. Okay, so we're going to use the formula D equals RT. All right, so use the formula to find out how fast you need to drive 252 miles in 4.5 hours. So 252 would replace what? Distance, rate of speed, or time?
Distance.
So 252 would replace distance. Equals R. Do we know the rate of speed? Do we know the rate of speed?
No.
No. But we do know the time is 4.5, right? So rewritten, 252 equals, instead of writing R times 4.5, I'm just going to rewrite that as 4.5 times R. There's an equation I can solve. And I know you guys did basic equations last year. Did you guys do basic equations? Okay. What do I have to do to both sides to get R by itself?
Multiply them by 4. No. Yeah, multiply them by 4.5.
Not multiply.
Divide them.
Divide both sides by 4.5. Divide by 4.5, right? So 4.5 divided by 4.5 is 1, so I get 1R. On this side, 252 divided by 4.5, well, I'm going to have a little scrap paper over here. So 252 divided by 4.5. Well, you guys should remember that when you have a decimal outside, you need to move the decimal point 1 over. You guys have seen that before? So it's the same as dividing 2,520 by 45, right? Does that ring a bell, guys?
Yeah.
So does 45 go into 25? No. How about 45 into 252? Well, that's about 50. What do you think? Think how many times?
3.
Well, let's see. I'm going to count by
6.
5.
5.
let's try 5, right? Let's see what happens. 5. 5 times 45. 5 times 5 is 25, carry the 2. 5 times 4 is 20, plus 2 is 225, right? Hold on, did I do that right? Yeah, 225. So the remainder is, can't do 2 minus 5, so that becomes a 4. 12 minus 5 is 7. And 4 minus 2 is 2. So yeah, 27 left over. So yeah, I couldn't do 6 times. So now I bring down this 0 and I have 270. I'm sorry about my handwriting, guys. I'm trying to get better at it with this. How many times do you think 50 or 45 goes into 270?
6.
6 times? Let's see. 6 times 45. 6 times 5 is 30. Carry the 3. 6 times 4 is 24, plus 3 is 27. Yep, 270. So I don't have a remainder. That means my missing piece, R, has to equal 56 or 56 miles per hour. Okay? All right. Real quick, there was something I was going to say, and it just escapes me right now. All right. Back to any questions on 17 to 25? I know we just did 2 of them. Okay, ready for the next section? 26 to 33. 26 to 33.
32.
32? All right, let's talk about Sage. Oh, I know what I was going to ask. Did anybody print out the answer key? Just making sure I don't make mistakes. Did anybody print it out?
I did.
Okay. So do me a favor. If I make a mistake, you tell me, okay?
Okay.
All right. Sage travels around a go-kart track every 3 minutes. Marcus travels around it every 4 minutes, and Thomas travels around it every 6 minutes. They all start together. How long will it be until they all get back to the start at the same time? What does this sound like to you guys? What kind of problem?
Addition.
Okay.
I don't remember what it's called, but I know how to do it.
Okay, how do you do it?
So like if Sage travels goes around every 3 minutes, Marcus does it every 4 minutes, and Thomas does it every six minutes. So I'd start with Sage, and well, actually no, I'd start with Thomas, and then you'd go like 6, and then you double it, and then so you get to 12, and I'd stop at 12, and then you do Marcus, and it'd go what's it called 4, 8, 12, and you stop because they're equal, and then Sage 3 minutes, 3, 6. I'm having a brain fart. 6, 9, 12.
Okay, so now Sage gets around the track in 3 minutes, and then again in 6 minutes, and again in 9 minutes, and then again in 12 minutes. Right? Marcus, 4 minutes, the 8-minute mark, and the 12-minute mark. And Thomas is at 6 minutes, 12 minutes, and so on. Right? Now, you recognized right away that the least common multiple, that's what you were meaning to say, right? The least common multiple of 3, 4, and 6 is 12, right? So yeah, at the 12-minute mark, if they all start at the same place, they're all going to be at the same place after the 12-minute mark. So that's the right answer. All right? Are we good there? Are we good here? Okay. 26 to 33, anything else?
I just have a question about 33.
Okay.
Because I just want to know, like, would the answer be 16? Because that's like the most you could do.
Okay. I think I get what you're saying, but I want you to think a little bit closer about the exact wording of this, okay? Louise makes bags of party favors. She has 16 stickers and 24 bracelets. She wants each bag to be alike. That means they're all going to have the same contents, right? And she needs to use all the stickers and all the bracelets. What is the greatest number of party bags she can make? So if she makes 16 bags, each one of them would have one sticker, right? Who asked?
Never mind, I get it now. I didn't realize that it said you had to use all of both things.
Yeah. So this one you're finding the greatest common
Factor.
factor, yeah. GCF, the greatest common factor, which the biggest number that goes into both 16 and 24 is 8. So it would be 8 equally alike bags. All right. All right, so back to 26 to 33. All right, let's go to the next section. 34 to 41. 34 to 41.
37.
37. This is one that somebody asked for. Okay. 3 friends share 1/2 pound of trail mix equally. How much will each person get? Well, I kind of cut this off. Okay, 1/2. Okay. So if 3 friends each share 1/2, right? So I'm basically taking 1/2 and dividing it into 3 equal parts, aren't I? Joan, you have a question? I'm sorry, it's so broken up I can't hear you, Joan.
I had the answer.
Oh, well, I don't care about the answer. I care about how to get to the answer. So 1/2 divided by 3 is the same as 1/2 times what? Somebody tell me.
1/3.
Time.
1/3.
Times 1/3, right? So 1/2 times 1/3 is 1/6. So each gets 1/6 of a pound. Now, visually, they kind of showed this to you. If this is 1/2 and this is 1, do you see how from here to here, do you see how those are 6 equal parts? 1, 2, 3, 4, 5, 6. So if I take half and break it up into 3 equal parts, there's 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. So 3/6 is the same as 1/2. So yeah, each one of them would get 1/6, 1/6, 2/6, 3/6. So together they get 1/2 pound. Okay. We all right with 37? All right, let's move onward. Guys, you have to understand, if you need to speak up if you have a question, because right now I only see 5 people on my screen because I have you off to the side. So I only see Grace, Ella, Joan, Izzy, and Brody, but that changes as people speak and stuff. All right. Hold on. No one asked about that one yet. Okay, 34 to 41. Any questions? 34 to 41. Okay. 42 to 47.
42.
42. Okay. This was a popular one for people to ask. And I think, honestly, there's something in here that I'm not sure you learned yet, but hopefully it'll make sense. And who's got the answer for me? Because I'm gonna actually have a different answer than what you have, but I'm gonna show you it's the same thing. So let's talk about 42. A photograph that measures 5 inches wide and 7 inches high is reduced to fit a space that is 1 inch high. Write a proportion that can be used to find W, the width of the reduced photo. Oh, by the way, I saw the answer key. I'm upset that they wrote X instead of W. That's not cool. Whoever did that, I'm gonna yell at them. I know who they are. All right. So a photograph is 5 inches wide and 7 inches high, right? And it's reduced into a space that is 1 inch high. So we need to figure out how wide it's going to be. This is called a proportion because it's going to be proportionally smaller. So one way of putting it, I always write down the two things you're comparing. So I'm going to compare the width to the height. Okay, that's one way of doing it. So the width is 5 inches and the height is 7 inches, right? How about with the new image? What would go up here? What would be the width?
One.
Nope.
W.
Yep, it says 1 inch high, so 1 would go here and W would go there, right? So that's the proportion. I actually think this is the same exact one that they did, right? Who has the answer key? What did the answer key say?
Yeah, that's what it is.
Okay, with my first class, by the way, today, instead of calling it width and height, I called it long to short, okay? Okay, what's the long side here?
The 7.
Yep, what's the short side?
5.
5.
5.
Okay, what's the long side here?
1.
1.
Yep, and the short side would be W. Now, this may look different, but if you look closely, look at these cross products. 7 times W. This has 7 times W. This has 1 times 5. This has 1 times 5, right? So mathematically, these two are the same. They're equal to each other, right? These two proportions are equal to each other, they're just written differently. That's what I mean by I did it a little differently with my first class. Okay, on this page, 42 to 47.
43.
43. Okay. A map has a scale. Let me put this in the new page. A map has a scale of 2 centimeters equals 5 kilometers. The distance between two cities on the map is 31.2 centimeters. What is the actual distance between the cities? All right. So once again, I like to write the words that we're comparing. So this is map to actual. Okay. The map, 2 centimeters on the map represents 5 kilometers in the actual world, right? On this side, what do we know? Is 31.2 on the map or is it the actual?
On the map.
Yep. So 31.2 on the map would be a number I don't know, so I'm going to use x in place of it, right? So 2 times x is 2x, and 5 times 31.2, I'm going to use scrap paper over here. 5 times 31.2. 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1 is 6. 5 times 3 is 15. So 1,560, but I got to move the decimal 1 over, so it's 156. Now what do I do to both sides? To get x by itself, I divide by 2, and I get x equals, how many times 2 go into 156? 78? That sound right? Right. So x is equal to 78. So it's 78 kilometers in the real world. All right. Any questions there? Remember, keep checking my answers, answer checker. I don't remember who you are. I mean, I never got your name. I just heard somebody has it. Who's got it?
Me.
Okay, I don't know who me is.
Oh, Ryan.
Ryan, gotcha. Thank you, Ryan. You keep checking my answers, please. All right, 42 to 47.
46.
Yep, new 46 would be one that people ask about. Okay, so, all right. Courtney needs to wrap this gift in a box which is 1 1/2. Yeah, you know what? Hold on. This bothers me. I want to make it bigger so I can write more. So give me a sec. You're gonna see a little overlap. Okay. Sorry, you now you're seeing like a little bit of what's on my screen up here from Zoom. So Courtney needs to wrap this gift box, which is 4.5 inches wide, 6 inches long, and 3 inches tall. What is the surface area of the box? So I want you to think about this. All right. I'm just going to be writing some notes that I'm going to end up deleting, but I just kind of want to talk about this. Do you see that this is the bottom of the box, and this would be the top? You see how these two are related? And this would be the right side, and this would be the left. Do you guys see what I'm saying? If you unfolded the box, if this is the bottom, this would be the top. This would be the left. This would be the right. What would this be? What would this be?
Front and back.
This would be front. This would be back, right? So do you see bottom and top, left and right, front and back? You guys all right with that? If I were to unfold the box, or fold it up, I should say?
Yeah.
Okay. All right, so now I'm gonna erase this. So let's discuss. Ready? Let's do the bottom of the box, right? Bottom, top. Let's do the bottom and the top, right? This is what by what?
4.5 by 3.
Not by 3,
4.5.
by,
6.
yeah, do you see why it's 6? This is 6, 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 right? So it's 4.5 by 6, which would be 9/2 times 6/1. You guys pretty okay with how I got 9/2? Okay, which by the way, I would simplify 2 and 6 before I multiply. So that's a 1, that's a 3, and I end up getting 27/1. So the area here is 27 inches squared, and the area here is also 27 inches squared, because the bottom and the top are going to have the same. All right, let's do the left and the right. Left and the right. This is the right side, this is the left side. What are the dimensions of each of these?
3 by 6.
3 by 6. So this is 18 inches squared, and this one is 18 inches squared. All right. Now we're going to do the front and back, front and back. What are they?
4.5 by 3. By 3.
Yep. So 4.5 by 3 would be 9/2 times 3/1, which is 27/2, which is 2 goes into 27, 13 times with a remainder of 1, so it's 13.5. So the top and bottom are both 13.5 inches squared. 13.5. All right, we okay with that? So now we add them all together. 27 and 27 is 54, plus 18 and 18 is 36, plus 13.5 plus 13.5 is 27. So if we add up the surface area of each of the 6 different rectangles, 4 plus 6 is 10, plus 7 is 17, carry the 1. 1 plus 5 is 6, plus 3 is 9, plus 2 is 11, 117 inches squared. We all right with that? Okay. Let's ask, are there any other questions from 42 to 47? We're good on 42 to 47? Okay. Next section is 48 through 55. 48 through 55. I see you, Andrew.
For 55, I was just wondering, could you pick more than one option?
I don't remember seeing 55 yet, so let's read it. I haven't seen this question in a year. Okay. So we need the graph for this. Hold on, I'm gonna put them side by side. Let me just go back and get the graph. Give me a sec. I need to make this smaller so I can see. The bad thing about Zoom is when you're running a Zoom, you get this thing at the top of the screen that you can't. Okay. Can you guys just mute yourselves? Okay. It might be kind of hard to read because it's a little small, but in order to get it, I had to do this. Okay. So now these two are together, right? All right. The histogram shows the result of a survey which students were asked how many times per week they study. So 0 to 2 times, 3 to 4, 5 to 6, 7 to 8, 9 or more, right? Am I reading it right? I know it's a little blurry, and I apologize for that. Which of these are questions that can be answered using the graph? So let's look at question 1. How many study sessions do the students participate in each week? Can we figure that out from the graph? Like the first one, is that 0 to 2 or 1 to 2?
0 to 2.
0 to 2.
And then 3 to 4?
Yeah.
Yeah, I would never make a histogram like this. Not equally spaced. I don't know. All right. So can we figure out how many study sessions? I know there's 4 students in this group, but they could all be 0, they could all be 2, they could all be 1. You could have 1 that's a 1 and 3 that are a 2. We could have 1, you get what I'm saying? So we don't know how many sessions there are. We know that they're in a range. So we can't say for sure that, you know, the exact number of study sessions. So that's out. How many hours do the students spend studying each week? Once again, we know that there's 4 students in this range, right? Just these 4 students alone could be from 4 times 0 or 4 times 2. They could be anywhere between 0 and 8 total hours. So once again, we can't figure out exactly how many students, how many hours they spend studying. Do more students study 3 to 4 times a week per week, or 7 to 8 times a week? Well, there's 8 students in this group and there's 6 students in this group, so we can answer this question. We can answer this question. And then, how often do you study? Does this histogram have anything to do with you? No. So only C is an answer that we could answer based on what's given to us, right? We can get close to answering some of these other questions, but we can't answer them for sure. And that's the point of this question is, you know, what can we use of this data and what can we not use of this data? All right. Okay. Let's go back. So 48 to 55. Any other questions on 48 to 55? No? Okay. And finally, 56 to 59. 56 to 59. We're good there? Okay. All right. Good. I'm glad. Let me close out of this. Back to this. All right. Do you see where it says loading notebook? And it's loading pages? You guys see that?
Yeah.
Okay. All right. We got Elmo again. Hi, Elmo. Note-taking packets I talked about with you guys. Quiz tomorrow I talked about with you guys. All right. We went over the summer packet quiz. I'm going to go to Google Classroom in a moment. Okay. So let me unshare and share. All right. You guys remember that you have the Khan Academy due this weekend, right? Any confusion on what is there? I know I haven't really gone into anything new yet with you guys, mainly because I wanted to answer the summer packet questions, and also I wanted to be able to, and I wanted to be able to, what do you call it? What was I going to say? Oh, get you guys used to using Khan Academy. All right, those are the two things I'm trying to accomplish so that when we get to new stuff, it'll make more sense. I'm going to assign you guys an Ed puzzle video, okay? And in 6 minutes, we're going to come back and talk about it. So give me 1 second to assign it to you. You're going to end up seeing it in your Google Classroom. All right. Assign. You guys are my red 4. Okay. In your Google Classroom, you should find this thing. All right. In about 6 minutes, I'm going to call you back, and then we'll talk about this. All right. So you guys see the Ed puzzle? All right. Get started. I'm gonna meet you back here at 12:22. All right. Go ahead. Get started.
Mr. Lab,
Mm-hmm.
my internet went out like a minute ago, so I didn't hear what you wanted us to do.
There's an Ed puzzle on Google Classroom.
Okay, thank you.
No problem.
Has the ed puzzle been posted yet? Because I'm not seeing it.
Refresh your Google Classroom under classwork.
I see it now.